Right, we're also going to do numbers 45 and 72 from section 1.6, commonly asked questions. Number 45 actually looks like a single radical equation, but we're going to solve it also, well, instead as a U substitution problem. When you have a single x that doesn't have an exponent on it, it's actually a 1. And a square root, remember, can be written as a 1/2 power. So once we rewrite the equation, it's a little easier to see how U substitution will be used. We're going to start off by letting our middle term variable equal our U. That little block is what U is equal to. That also means that our lead term we can rewrite as U squared. Now we'll do our initial substitution. Get U squared minus 13U plus 40 equals 0. That is a type 1 trinomial. I'm going to factor it, but remember, if you're allergic to factoring, you can always use the quadratic formula. Just remember that you're getting U's, and you'll still have to solve for X. All right, this factors into U minus 8 and U minus 5. I'm going to set each one of my factors equal to 0. So we get U is equal to 8 and U is equal to 5. Unfortunately, when we look back, we weren't looking for U, we were looking for X's. So we're going to unsubstitute at this point. Remember, the U squared never gets used again, so we cross him out. Now, U I'm going to replace with this X to the 1/2. And as we learned with rational exponent equations, when we need to get rid of an ugly exponent, we're going to raise it to the reciprocal power. The reciprocal of 1/2 is 2, but if you do it to one side, you'll do it to the other. On the left-hand side, the 1/2 and the 2 become 1, so we get x, and 8 squared will give us 64. For the second case, again, to get rid of the 1/2 power, we raise it to the reciprocal. But what we did to one side, we'll do to the other. Here, the 1/2 and the 2 cancel each other out. The x comes straight down, and 5 squared is 25. Finally, we're going to look at number 72 as another frequently asked question from 1.6. We have 4. Absolute value of 1 minus 3/4 x plus 7 equals 10. We're going to start off by isolating our absolute value. So I'm going to start by moving the 7 over to the other side. Remember, when it crosses the equal sign, it becomes a -7. Now we have 4 times the absolute value 1 minus 3/4 x equals 3. Now I could divide both sides by 4, but it's going to make a fraction. Remember, like we said in class, remember who you are. We can actually distribute that 4 through the absolute value. 4 times 1 is going to be 4. 4 times -3/4 is going to give us a -3x. Equals 3. Now we don't have to multiply the other side or the right side by 4 because we're just distributing that 4 through the absolute value to get rid of the fraction appearance on the inside. Now we've got the absolute value isolated, so we're going to write our two cases. Case number 1, pretend that the absolute value is not even there, and we're going to solve that. Case number 2, remember, pretend that the absolute value is not even there, but this time multiply the right side by a -1. I'm going to start by moving the 4 over to the other side. We get -3x is equal to -1. After dividing both sides by -3, we get x is equal to positive 1/3. That's one of our answers. Again, on case number 2, move the 4 over to the other side. Now we have -3x equals -7. After dividing both sides by -3, we get x is equal to 7/3. All right, I hope that helps.